Beep, beep. Hmm. Oops. Hello, we're back for now day 4. This is probably the last one that I'm going to do, at least as far as live coding for a review for CSCE 155E at the University of Nebraska-Lincoln. Hopefully I can get this done quickly because I don't have too much time. I've got somewhere to be. But we might only end up getting to do the first part, or hopefully if I don't finish it in this live stream in the next half hour, I'll go ahead and finish it up and send it out and post it on Piazza for everyone. But let's go ahead and take a look at the problem statement here. So you've snuck into another supply closet. This time it's across from the prototype suit manufacturing lab. You need to sneak inside to fix issues with the suit, but there's a guard stationed outside the lab. So this is as close as you can safely get. As you search the closet for anything that might be of help, you discover that you're not the first person to want to sneak in. Covering the walls, somebody has spent an hour starting every midnight for the past few months secretly observing this guard post. They've been writing down the IDs of one guard on duty that night. The elves seem to have decided that one guard was not enough for the overnight shift, or it seems to have decided that one guard was enough, as well as when they fall asleep or wake up at their post. And that's the puzzle input. So for example, we've got this. So we've got a date timestamp in near ISO format. Guard number begins the shift. They fall asleep, then they wake up, then they fall asleep, then they wake up. So they fall asleep 5 minutes after their shift starts. They wake up 20 minutes later. They're awake for 5 minutes and then they fall asleep again, and they're asleep for the next 25 minutes. Timestamps are written using that near ISO format. The guard falling asleep or waking up is always the one whose shift most recently started, because all awake sleep times are during the midnight hours. So we're restricting our attention here to midnight to 1 minute before 1 a.m. So 60 minutes. And only that's relevant to this. So it looks like they visualized this input up here. So again, guard number 10, this first line right here, he fell asleep at minute 5, and then he woke up at minute 25, right, 2-5 right here, and then he fell asleep again at minute 30, and then woke up again at minute 55. So all these hash marks here are when that guard was asleep. The columns are et cetera, et cetera. So awake is shown as a dot. Note that the guard counts as asleep on the minute that they fall asleep, and they count as awake on the minute that they wake up. So for example, guard number 10 wakes up at 25. He is awake, all right? And 25 is marked awake, but on 30, when he falls asleep again, he is marked as asleep. Right? So you figure out that the guard most likely to be asleep at a specific time. You might be able to trick that guard into working tonight so that you can have the best chance of sneaking in. So you've got 2 strategies here. Looks like we're only doing 1 strategy. The second strategy is probably the second part. Find the guard that has the most minutes minutes asleep. What minute does that guard spend asleep the most? Okay. So the biggest challenge to this one is probably going to be getting that formatting and that temporal relationship figured out, and then getting the input file actually read. And it does look like it's completely out of order here, so I'm going to go ahead and cut and paste this. 2018, 12. This is day 4. It's not the 6th. This was day 4, right? Let me double check that. Yeah, day 4. So I'll label it as 4.input.txt. Right. And I'm probably also going to want to have that test. So I'll go ahead and cut and paste that for now. And I'll probably also want that test input, because this is a pretty complicated problem. So I'm going to definitely want to test that. So already I see that probably we're going to want to be in temporal order here, that is sorted by the date time, and unfortunately this one is not. So before I even begin my program, I'm going to get that into a sorted order. I'm at the command line here. There's a nice little utility called sort. Sort 2018 1204.input. Of course I could have done this in C very easily, but this one, because it's in a near ISO format here, year, month, day, and then time on a 24-hour clock, it's guaranteed that it's lexicographic order. This is one of the advantages of using an actual ISO date time format. So I'm going to go ahead and redirect this in 2008 day4.input.txt. Right? And I'm not going to use this, I'm going to use this. And you now see that it is sorted according to the date. Right? Again, I could have done this in C. The way that I would have done it is I would have read in every single line and then just called qsort using a string comparison function like we did on a previous day. And then I would have had everything, you know, in that order. This saves me some coding in C though. Not that much. It probably really only saves me a line of code, but so be it. All right, so let's go ahead and duplicate this into 4A. Right. I'll be reading in for input.txt for write. So again, we're going to be reading in every single line. We're not doing frequency, but there is the basic starting code for reading every single line of the file. Let me go ahead and increase the size here. There we go. So we've got a line that looks like this. For each one of those lines, we're definitely going to want to extract that minute. And then the rest of this, we're definitely going to want to extract the guard number. And let's see if that guard ever shows up again. It looks like that he shows up like several times. So the way that I'm going to model this is I'm going to keep an array of integers that represent whether or not they were a count of the number of times that they were asleep at that minute. And I'm going to need to keep a separate one for each guard. So I'm actually going to encapsulate this into a structure that represents a guard. So we've got his ID, and then we've got their minutes, right? And that's going to be 60 of them, right? Initially, we're going to want all of those to be 0. And then as we go through and parse and we look up their ID, and then then we'll increment their minute. You know, then given when they fell asleep, given when they woke up, we'll have a section of their time that we can increment that they slept this many minutes. For example, let's go back to the visualization. Right, this line and this line would basically be superimposed. So all of these would be 1s, and then where they intersect here, that would have a counter of 2. All of these, all of the times when they were fully awake, those would all be 0. Then these would be 1s again, right? And then these would be 0s again. So I want to get that model at least in memory as a first step to see that I am actually reading this data correctly. And then once I've got it in memory, I can it's a fairly straightforward then to go through each one of those records, count up the number of elements that are non-zero to find the guard that sleeps the most. And then once I've got the guard that sleeps the most, just go through and find the largest value in that range, and that's the minute that they slept the most often. Okay. So there is there's that. It's actually not going to be as simple as I'm hoping. Let's go ahead and I need to give it a name. Guard is good enough. I don't know how many guards there are. We can go ahead and do some command line stuff here to look. More 2018 04.input. All right, so if I more it, I can read it. But what I want to do is I want to look at all the guards. All right, so there's all the unique. There are all the guards, but of course some of them are repeated. Looks like no guard has an ID more than 1,000 and there are no negative values. I don't want to just create a huge giant array that could hold like 10,000 guards because a lot of them would be undefined. So what I'm going to do is I'm going to put this through awk and I'm going to print, let's see, this would be 0, 1, 2, 3, 4. I think so, 4. All right, there are all the guard numbers. Right, awk is a command line utility here that you can grab. By default, it's going to use white space, so I'm grabbing the 0, 1, 2, 1, 2, 3, 4th token out of all of these things, and then I'm going to sort them. Right? And you'll see that a lot of them are repeated. So I want all the unique ones, right? And that gives me a list of all the unique guard IDs here. Now if I do a cut and paste over here and do a new file, I can see that, oh, there are 23 of them. So I know that I need an array of size 23 to hold all of these unique guards. I don't want to save that. Another way that I could have done that directly from the command line is to pipe it into another utility called word count. Count me the number of lines and I get 23. All right. Now again, this is it was intended as a review for CSCE 155E, but this is kind of a review. This is kind of a preview of what you would see in a Unix programming course, where I'm piping all these different utilities together to get to crunch the data at the command line. I'm just listing the file and then I'm grepping it out so that I only get those particular lines that I'm interested in. Then I use awk to get that particular column that I'm interested in, and then I sort it. And then I only take the unique values because I want to know how many unique values there are. And then I use another utility to count it up for me so I don't have to do the heavy lifting. So I know that there are 23. 23 is not that big. I'll go ahead and make it static. Guards of 20. There are 23 of them, right? I could also, now that I think about it, I could also go ahead and pre-build them since I've got these. Let me go ahead and put this up here. Int IDs. And I'll go ahead and cut and paste those. That's not valid C. All those hashes are a problem there. So what I'm going to do is I'm going to find and replace all the hashes with nothing, but only in the selection. All right, there we go. All right. Now that's still not valid C. I'm taking the opportunity here to show you a few tricks too. And these are not unique to Atom, by the way. You're going to have every IDE or every text editor worth its salt is going to have some way of doing all of this stuff. But I need, commas, right? So I could sit here and 23 times going like this, whatever. But what I'm going to do instead is I'm going to go ahead and use this selection. I'm going to use a regular expression, and again, this is probably a preview for a Unix course. I'm going to go ahead and replace every end-line character with a comma. There we go. And now I've got a comma after all of them. I don't want that comma after the last one, though. Okay. And that's good. Right? It's taking up a lot of space. If you want to, you can come back and format it nicely. I don't have a built-in formatter automatically. That'll just take it and put it on just a few lines, but it's okay. I'm not going to look at that again. What I am going to do, though, is I'm going to go through each one of those guards, and I'm going to initialize that guard to that ID. So for int I equals 0, I is less than 23. In fact, now I'm going to put 23 in there, and I plus plus. So for that guard, I'm going to give them the ID guard sub I dot ID is equal to ID sub I. Right? I could have gone and sorted those. If you want to do that, then you'd have to strip out the hash here and then sort them again. But then it's only going to be a lexicographic sort, so it's still not even going to work. So never mind. I don't care about the order. We can always sort them later. But I do want to go through and make sure that all of those minutes, j is less than 60, j plus plus, are initialized to 0. So guards sub I dot minutes sub j is equal to 0. Because again, there's no guarantee on what's in that memory when I created that thing. It could be garbage. it could be 5, it could be 42, whatever. I've now initialized those 23 guards. I'm going to open up the file, and then for each line, what I'm going to do is I'm going to look up the current guard. All right. Well, if the line is of this form, right? If it's like this, a guard 89 begins shift. So if the string contains the string guard, right? If the line contains the word guard, then I know that I've started a new shift with a new guard. So, and I don't know how big these things were. Certainly under 100. So we're fine on that. So if so I'm going to put if buff contains guard as a substring, then I'm going to want to start on a new guard. Right? I'm going to go find that guard, and then for the next few strings, he's going to be awake. He's going to be asleep. I assume that he's always going to. Yeah, there's no guard here that starts their shift asleep. They start awake, of course, because they clock in, and then they fall asleep, and then they wake up, fall asleep, wake up. I assume that also that they end their shift by waking up, that they don't they're not carted out of their asleep. So the one way that you can find out whether or not a string contains a substring is there's a function called strstr. Locate a substring of a string. I've got my needle, which is going to be the guard, and the haystack, which is the line, and it's going to return a character pointer, right? And the way that the return value here, if needle is an empty string, haystack is returned. If needle occurs anywhere, nowhere in the haystack, null is returned. So if it's not equal to null, if str, I'm looking in the buffer, I'm looking for the string guard, and if it's not null, then I know that I found my needle, right? And so I will start with a new guard, okay? Otherwise, I'll go on to the next line. And with a new guard, I'm going to want to find the guard record, and then process each line. I might want to change this into a nested while loop here, actually. But we'll think about that in a second here. I want to find the new guard, so let me go ahead and create a function here. Int find guard by ID, and we're just going to do a basic, straightforward linear search here. Guard, guards, all right, and int ID. Right? And what we're going to do is we're going to, for each guard, we also have to put in the size. For each guard, if guards sub I.id is equal to the ID that we're looking for, we'll return I, the index at which we found it. Otherwise, we'll return -1. We didn't find it. Okay. We could use B search here. We could use binary search. We could sort it by, and then I'd have to write a comparator, all that stuff. But I'm going to find the guard by ID, and that's going to be guards and then ID. But we need to get that ID. So how do we get that ID out of there? It looks to me like the times when they begin their yeah. So let's go back to the example here, because does the beginning of the shift matter? I guess begin shift, they begin their shift 2 minutes earlier, but they fall asleep 40 minutes after. So I'm going to assume that it doesn't matter and cross my fingers and hope that that assumption doesn't come back and bite me. All I want is the number here, right? So you know what? Let's go ahead and grab everything. So I'm putting this over here as a reminder. We'll want int year, month, day, hour, minute, and ID, right? Those are all the tokens that we could possibly get out of this thing. And kind of like scanf, remember, is reading from the standard input. We're going to be reading from a string, though. we're going to be reading from the buffer. And the format that we're going to be reading here is, well, this format. Right? Probably want to chomp it out too then. Let's say that buff of strlen of buff, buff -1 is equal to the null terminating character. There we go. Because I don't want to have to deal with that in here. So this is going to be an integer. This is one token. This is another token. Integers. This is another token. This is another token. This is the token that we're really interested in, though. And now we need to pass each one of those things in by reference. Month, day, hour, minute, and ID. All right, there we go. Find the guard by the ID. And then, you know what, I'm just going to printf, as a really quick sanity check here, I'm going to print the year, or you know what, the minute and the guard ID. So, minute and ID. And let's just see that this works for now. 04A, there we go. Bards, there it is. Okay. Oh, and we're getting a segmentation fault. So there's definitely something not right here. And we're not getting it even at least one. So guard begins shift. Make sure that my use of scanf is correct. That's S, and then the format comes later. All right, darn it. Thought I'd be clever in using scanf, but nope. Year, month, date, hour, minute. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There are definitely 6 of them. Let's just make sure that's not the issue. Oh, that's because the file's not there. No, it's right there. Oh, dot. All right. There we go. Not clean, so let's go ahead and go with this. I just want to make sure that I'm reading the file correctly here. So 1 and 89, that's the minute, and 89, that works. But then we're skipping all these lines in our current loop right now. And then it would be 2 and then 787. Yep. And then it would be 0 and 499. I'm convinced that this works. Let's jump down to the bottom. And the last one should be 50, sorry, this one, 03 and 1481. So 03 of 1481, yeah, okay. I'm convinced that that small part is working at least. Let's go ahead and restore that. This will tell us, yeah, if it's ever -1s. Okay, that's good. So we've started with the new guard. Now what we need to do is for, you know, while, let's go up to the top here. While we don't reach the next day, we're going to want to read the line, and I'm really only interested in this, whether or not it contains falls asleep or wakes up, right? So come over here and rethink my inner, maybe doing this with an inner loop here. So we get the next line no matter what. So what I'm going to do is I'm going to keep track of a current guard index. And initially, hopefully, it'll be set by this, right? Then I've got the guard's records. So on the next iteration, when we get the next line, it's either going to be wakes up or falls asleep, right? So we also need to keep track of their current state, their previous state at least, or the previous minutes basically. So else if, all right, so we're here right now. We just need to determine whether or not they've fallen asleep or they've woken up. And then we're going to want to keep the previous number, the previous minute, and then we get the current number, and then that tells us if they went from, if they fall asleep, then they go to wake up. That's when we want to take a snapshot of that time and put that into our record of the current guard. Okay. So we're only interested when they're asleep. So let's go ahead and keep a int begin sleep. Right? And it doesn't matter what I initialize that to, int end sleep. Right? So if str, the buffer contains, what was the exact, falls asleep, right? Then, or it's not equal to null, excuse me. Then begin sleep is going to be, well, we don't need to, we need to use scanf again, right? Scanf, we'll get all of those, throwing most of them away. Actually, no, it's a different format now, right? It's now falls asleep. And so we don't have any of this stuff. And so I don't have the ID either. But I am interested in that minute. So begin sleep equals minute. Right? Else if str of buffer was wakes up. Is that wakes up? Yep. Is not equal to null. Then again, use the scanner. End sleep is equal to that minute. And now I'm going to, again, we're assuming that they always start a shift awake. So it can only ever go begin sleep, end sleep, begin sleep, end sleep. And we're also assuming that they can't end a shift sleeping. Again, I don't know if these assumptions are correct. We'd have to look at all of them. So I would want to update the range here at this point when they've ended their sleep. So for int I equals 0, I is less than, they begin their sleep and then they end their sleep. So I want how long that was. So if I take their end sleep minus their begin sleep, right? So if they started at 5 minutes and then they ended at 10 minutes, that would be 10 minus 5. That's 5 minutes that they slept, right? Actually, no, sorry. I actually want to keep track of the minute that they actually slept. So for I starting at begin sleep, I is less than begin sleep plus end sleep. Or sorry, no, end sleep, just end sleep. I plus plus. I'm going to increment their sleeping counter. Like guards, I want the current guard, and I want his minutes and his ith minute, and I'm going to increment that. Okay. I think that that's good. Now I'm going to test this to see if I get the same results as the test input. So I think it was called test that yeah, rename this to 04.test, and that's what I'm expecting. Good. All right. So we've got this test input here that looks like this. I want to reproduce this kind of graphic right here, right? But I'm going to collapse it down so that this line and this line would be superimposed on each other, and I'm going to get those zeros, ones, 2, and then a bunch of ones, and then zeros again, right, to make sure that this actually works. Let's go ahead and get rid of those for now. So to do that, after this is done, for int I equals 0, I is less than guards, or I guess it was n, I plus plus, printf number, and then %d, that's the ID. space. This is the guards sub I dot ID. And then after that, I'm just going to print the actual number of the counts. So for int I equals 0, I is less than 60, I plus plus. Print these. And guards dot minute of j. I should have used j here, sorry. There we go. And after all of that's said and done, go to the next line to make it look pretty. Okay. Minute. Oh, I didn't declare these? Oh. So here's a review on scoping. I declared all of these variables inside this if statement. That means that they only exist within the confines of this opening curly bracket and this closing curly bracket. I'm using them, however, in all three of these. So let me go ahead and bring them up there so that now their scope is within this closing, with this enclosing while loop. And now it's going to be okay for everybody. And one other thing that I wanted to put in here was else some sanity check here. Printf line %s does not conform to expectations. Right? And then I'll print the buffer. Okay. And now what that'll do, that'll tell me if any of my assumptions were wrong, or if I get to the end of the file and you've got a string that doesn't contain guard, falls asleep, or wakes up, right? Minute or minutes, sorry. So minute, where was it? Minute. Huh. There we go. Minutes. There we go. All right, and let's run this. All right, it's way too long. I put a space in there. I can make that a little bit more compact. There we go. I thought I put it in test though. Where's test? So, okay. Well, yeah, but I'm initializing it with all of them. I should be looking for. Oh, in the test they had different IDs, didn't they? In the test they had IDs 10 and 99. Okay, fine. That means that when we searched for those guards 10 and 99, they never showed up. So let me go ahead and comment out these and put in 10 and 99. And now they'll show up as the first two. There we go. And these are the ones that I want to pay attention to. The rest of them are just noise because they don't exist, so they were never pulled out. They were never encountered. So let me compare this with the graphic here. Okay, so zero in on that. Let's look at the graphic here. Now again, if you superimpose 10, then 0, 1, 2, 3, 4, 5. He's always awake for the first 5 minutes, right? And then he's asleep at some point over those 2 different days at every one except for the last 1, 2, 3, 4, 5 minutes. And in the middle here, oh, I guess there is 1 minute here, right here on minute 29, where he's awake for both days, so that becomes 0. And we've got an intersection of 2 there because he's asleep for minute 24 on both of those days. And then the other guy, it looks similar, except there should be a 3 in there, it looks like. So we do have a bug somehow. Right there, that column right there on 45, it should be 3, and I'm not seeing a 3 there. But otherwise it should be, oh, you know what, duh. It's this one, and this, no, it should be 3 right here, all right? I'm ignoring this, this 10 over here. So that should be 1, 1, 1, 1, and then we go to 2. So I said 4 ones, that's correct. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then this is the one that should be a 3. Actually, there should be several more 2s there, it looks like to me. All right? So make sure that guard 99, that last day there, it looks like it's not getting processed to me. So none of the errors. Oh wait, here. Wake does not conform to expectations. There. Wake line. Let's find that guy. Wakes Oh, you know what? So it does not conform to expectations because what did I do up here? I chomped it out, right? Where's that chomp? Right there. I chomped it out thinking that there was an endline character, but on the last one, there is no endline character. So one way of really quickly fixing that is going to be insert that endline character. Run that again without even recompiling here, and now it looks right to me, right? Let's make sure, absolutely sure here. So where we get that 3, and then we should get 2, 2, 2, 2. So 4 2s, and then 1, 1, 1, 1, 1. All right, that looks really good to me. So let me come over here, and before we go through the full test here, we're not done. We have to find the guard with the most number of missing minutes, right? So int index of most missed minutes, right? We'll assume that it's 0 at first. Then for each one, what we're going to have to do is we're going to have to go through and count up the number of intervals that are non-zero. So once again, going through all those int count, or number of intervals sleeping. Actually, let's go back here and make sure that we understand. I'm not sure whether or not so here's strategy 1. Find the guard that has the most minutes asleep. Which minute does that guard sleep the most? So I'm now reinterpreting this. Num minutes sleeping, right? And what we're going to do is there's a count in that interval. Guards sub I dot minutes sub j, right? That's the count. So we'll simply just add that to our running total here, right? And if num minutes sleeping is greater than int max minutes sleeping, then we found a guard that's even sleepier. So index of most missed minutes is going to be updated to I, okay? And then let's printf. Sleepiest guard is going to be %d. And the line, I've got the index here. So what I need is guards, sub that dot ID. Let's go ahead and put a hash in there to remind us that it's an ID and not an index. Oops. There we go. All right. And it looks like 99 according to this. Is that right? Guard 10 spent the most minutes asleep, a total of 50 minutes. All right, while guard 99 only slept for a total of 30 minutes. So that's wrong. So let's actually go ahead and report it. Printf %d slept for %d minutes and the line, and then num minutes sleeping. All right. Let's see if we can match the expectation here. Guards sub I.id. All right. Okay. Sleepiest guard. So guard number 10 slept for 50 minutes. 99 slept for 30. Let's see. What was it? 50 minutes and 30 minutes. So those are correct. if num minutes, I never initialized this. Right. I'll probably get a better answer now if I actually initialize it. There we go. Go up here, still 50 and 30. I should be getting an index. Oh, duh. I never update the maximum, right? Is equal to, I need to update the index and the maximum in order for it to work. And so now I get that the sleepiest guard is number 10. Sleepiest guard. I can go ahead and get rid of this debugging statement. I can also get rid of these for now. I'm not going to get rid of that code until I'm done and handed it in. All right, so sleepiest guard is number 10. And then the final answer, of course, would be what minute does that guard sleep the most? And he slept most during minute 24. Okay, so what I'm going to want to do is I'm going to want to iterate. What I'm going to do, I've already got the sleepiest guard, right? Index of most used minutes. So for int I equals 0, I is less than 60, right? I plus plus. Most slept minute, right? So if guards sub index of most minutes, that's the guard who slept the most. If their ith minute is greater than the same thing, but most slept minute, right? Then I will update the most slept minute to be I. Printf sleepiest minute of that guard is going to be %d, and then the most slept minute. That'll give me hopefully 24. I might be off by 1, but everything was aligning with the 0th minute, so I don't think I am. We should get 24 out of this. Yep. Okay. So I am confident that it works for, let's get rid of this. I'm confident that it works for the test. Let's go ahead and do this and cross my fingers and see if it works for, oh, where's the file? It's no longer test, but it's going to be input. Input. Okay. Right. 44. Right. Except now that I'm remembering, I think we have to give our answer in a different format. The answer would be 10 times 44. Okay, so all I need to do is take 499 times 44, and that's my answer. I'm not gonna bother to go back and program that in, but again, cross your fingers with me. Yay, we did it. All right. Some of these, especially as they get towards the end, I have answered the wrong thing before, and it sometimes, for the first few, it sometimes tells you, yeah, it's larger, or yours is too low, or yours is too high, and it kind of gives you a hint. But then after, I've also submitted multiple wrong answers, thinking, oh wait, maybe I was just off by 1. It makes you wait for a minute, and then after a few wrong answers, it makes you wait for 5 minutes, and then it stops telling you whether or not you're too low or too high. So it does prevent you from cheating. I don't know that I'm going to have time to do it, but we will take a look at part 2. Of all the guards, which guard is the most frequently asleep on the same minute? In the example above, guard 99 spent minute 45 asleep more than any other guard or minute 3 times in total. In all other cases, any guard slept any minute asleep at most twice. Okay. Actually, I think that this is going to be pretty straightforward. Let me go ahead and duplicate this so that I don't do anything wrong with it. So the way that I'm interpreting this is guard 99, that minute 45 here, where it was a count of 3, that's the minute that we want, and we want that guard's minute. Okay, so basically we've got 23 guards, 23 rows, and then we've got 60 columns. Basically this is just a 23 by 60 table, and you're looking for the largest number in that entire table. the row and the column that correspond to that largest value, multiply those two things together, and that's your answer. Okay. So all I need to do is take let me get rid of all this stuff and start over, since I'm on B now. For int I equals 0, I is less than n, the number of guards, I plus plus, right? And for this one, it's actually going to be simpler because max value, right, is equal to 0. For int j equals 0, j is less than n, 60, j plus plus. If guards sub I dot their jth minute is greater than the max value, then that's what we're looking for, right? So let me go ahead and create two variables here, guard index and minute index. Right? You can initialize those to 0. It doesn't really matter, right? It's the max value that needs to be initialized. Guard index is equal to I, and minute index is equal to j. Right? So printf guard %d slept the most at minute %d, giving you a value of %d, and the line that's going to be so guards sub guard index dot id is what I want. Minute is going to be minute index, and then the final answer is actually going to be these two things multiplied together. Okay. Oops, compiling the wrong thing. It's now B. Guard 947 slept the most at minute 58. Is that the answer that we want? What is the ID of the guard chose multiplied by the minute you chose? Okay. Too low. There's some blah blah blah. So now you've seen what it looks like to get a failure here. Let's see. 947 by 947 times 58. That's correct, right? 54, 962, or 926, yep. So unfortunately, I'm not going to be able to spend too much more time on this. If you saw what went wrong, go ahead and leave a comment. Otherwise, I'll take a look at it later tonight when I've got more time and post on Piazza what I did wrong, or I'll just post on the video or something so that anybody who is watching this that's not in the class can get the benefit of that answer too. Okay? So again, this is the last day that I'm going to be doing this scheduled. If I get bored or something during finals week and I've got some time, I'll go ahead and try, but not announced previous to that. Otherwise, again, good luck on all your finals. Make sure that you study. Make sure that you come to the final exam prepared. And Merry Crimbus.